Well, this is the largest audience I ever had at midnight, I can tell you. It's great to see so many here, even at this hour. And I hope many of you, maybe all of you, will stay through this 4.5 hours. Maybe it's 5 hours, actually. Yes, it's 5 hours. And because there are really a lot of good talks all night through. I will talk about my journey from KTH to space, bit what I did that, and back, and what we do in space at KTH, a little bit overview of it, while during the evening you will, let's see, next, I have the points over there. There will be all these talks about the various aspects of research being done at KTH related to space, and even one talk which it's about the space relation to humanities and history and literature and things. They're very interesting, actually. And all of these talking here, maybe, except Sabine, are related to KTH Space Center. Well, my journey started here 1975, 42 years ago. I figured out that means I've almost been here half the time of campus. Scary. Actually, Sven Gran, who will talk here later, he has been over 50 years, so he's been more than half the time. So that's how I looked when I was a young first here at KTH. Did a lot of things, in addition to studying, taking care of parties, took a year off to do sailing across the Atlantic, because I always loved to travel. And of course, travel to space, that was the ultimate thing you could do. But this is not working very well. Now, here it comes. After studying here at KTH, I got a PhD, which I actually did at Stockholm University in particle physics. Became a researcher at CERN, doing particle physics and preparing for this huge experiment, Atlas, which is now running there at the LHC. And I thought that was really great fun. And then a friend of mine said, "Hey, Chris, I found a new job for you." I said, "I don't need a new job. I'm doing research in physics. What can be more fun?" Well, he said, "Actually, they're looking for astronauts." I thought he was joking. But the next day, he actually gave me this ad he had cut out of the newspaper. The European Space Agency is looking for up to 10 astronauts. And okay, I had then for many years had it back of my mind, if ever is a chance to go to space, well, okay, then I have to try to take it. So, of course, I applied, and eventually, in 2 years later, that's what it took, in 1992, I got selected as an astronaut, but then it took quite some more time. It actually took another 14 years until the end of 2006 before I finally was on the verge to go to space. And this photo I actually took myself. We came flying with the T-38 aircraft from Houston, where we were living and training, over the launch pad, and their Discovery space shuttle was standing there waiting for us, finally ready to go to space. And a few days later, we boarded there. We had some few guys who were helping us get into our seats through the hatch there. They closed the hatch, and then they went far away. No one wants to be close to the shuttle rocket when it starts, unless you're up there, of course. Actually, you later, more sleeping for some hours. Can you get some sound on this? Need some sounds. You can hear the rocket. Yeah, here it is. When that starts, then you wake up for sure. And it's a tremendous, powerful event. It's shaky, both physically and psychologically. But mostly I was just happy there in my spacesuit, finally on my way to space. And it's shaky, mainly because of these rock boosters on this new car with a few hundred horsepower. But these rock boosters on the side, they only burn for 2 minutes actually. Then they separated. They fell down in the Atlantic with the parachutes. Could even be reused. Then the ride becomes a bit smoother, but then the G-forces increases while as you burn off fuel and get lighter. And after takeoff, did this restart somehow? So another 2 days, and then we approach the space station, and we docked to the space station, which at this time in December 2006 was more or less halfway built. And our job was to continue building the space station. On board there was a crew of 3 who were living there permanently. They were out there for 6 months actually. Our trip was on for 2 weeks. The day after the docking, we did a first spacewalk, and that's when we were going to continue building the space station. So we had a part with us up in the space shuttle in the payload bay, which was brought out to the end of the space station as it was then, with robotic arms. Here's that piece on the robotic arm, and there we prepared it and we secured it in place with battery volt drivers, this one here. And anyone ever heard that they lost a tool in space? It was not this thing, but an extender to that one. A little bit embarrassing, I must admit. The following day we were going to retract solar arrays. These are huge things, about 30 meters long, which later had to be moved. But it didn't really work as planned. This was to be done by a command from the inside. But it didn't want to fold up properly, as you can see here. And this became a problem for the ground control to try to figure out how can we solve this. In the meantime, up there, we continued to do what we had planned and trained for several years. Here's the Spacewalk 2. We did some reconnecting electrical cables, some other work. Here you can see we have a camera with us, even when we are doing out there on Spacewalk. Working out the airlock. This is the Soyuz capsule, which the crew, the 3 guys up there, had with them. Always nice to tell your friends what you're doing. Here a little connection to Stockholm and the Crown Princess. And I was doing this frisbee trick, which was referred to, which showed what you can do in weightlessness, but they didn't like to kind of admit it as a world record. And then we got a call from ground control saying, hey guys, you better go out and do another spacewalk to fix this problem in the solar arrays. And that was a real challenge. I think that stopped. Was that because I did something? Let's see what happens now. It froze. It was cold out there, but no, not really. Well, now we restart. That's not a good idea. Okay, so anyhow, that solar array, we finally managed to get it solve that problem. And that was really challenging spacewalk because we had not trained for it. And we didn't know how to solve it. And it was really real-time work, solving problem together with the ground control. And finally we managed to solve it, and we could retract it, and we came home. Everyone happy. So that was a long preparation to finally go to space, but it was worth it. And the feeling to come into the weightless, to see the world down there, floating by, and the spacewalks, maybe the best of all. And this photo was taken during the first spacewalk by our commander. And it actually became known on some website for travels as the travel picture of the year 2006. Whereupon in a comments line somewhere down, someone had written that, oh, that's obvious fake, too good to be true, so that's Photoshop. But I say, no, I was there, so I know it's true. And what you see here, by the way, is New Zealand, here with the South Island, there's a North Island. So, let's see. Well, doesn't really want to, there it is. So, 2.5 years later, I got the second space flight. My boss had told me basically months after the first flight that, good job, we'll give you another flight, similar, we have a deal with NASA, but then that's it for you. After that, we need to send up people from other countries. Well, this is the launch for my second flight, which was exactly at midnight, the 28th of August 2009, local time. Here's 28th of August. Up there is actually 29th of August. a few minutes later, and you can see here how the shuttle goes up and it's not crashing down, but it goes into orbit around the Earth. So my two flights both went to the International Space Station, and I was part of building it, assembling it, and equipping it with things. Our second flight was mainly equipping it with things. And this is how it looked like in my last view of it with my own eyes. Well, actually, you can see it sometimes passing over sky, but then it's all just a dot, right? But this, when we left it in September 2009, and it's an amazing thing which has been built up there. The first piece here already in 1998, permanently manned now during 17 years, and in the beginning 3 people, now normal 6 people. It's huge. This is over 100 meters. All in all now some 450 tons. We built it partly because we want to learn how it is to live in space and build in space, to prepare to go further in space, but it also gives us unique opportunities for doing science. So it's really a big laboratory. And it's particularly the weightlessness up there, which is utilized for doing research, science, in many various fields, from biology, physics, medicine, because things behave differently in weightlessness. For example, you don't get convections. That's a candle on Earth, right? Warm air is lighter than cold as it goes upwards, and you get an air circulation. It doesn't matter in space that the warm air is lighter, so it doesn't go anywhere. So that means that you don't get the disturbance here by flow of air, and you can study, in this case, combustion in another way. And that's a lot of research in gases and fluids due to that. How does things grow in space when the roots doesn't feel the gravity, for example? The roots goes everywhere. You can understand how things grows. Medicine is a big field because a lot in our human bodies gets affected, often negatively, by the medical effects. And by the way, there is on KTH, there is a group who's studying physiology also in space in KTH. There's also radiation up there, which affects humans, and that's been part of my research. So one of the more exciting things is that during the Apollo 11, the astronauts there first reported that they noticed light flashes, and it was soon suspected that that must be to particles, subatomic particles in space who hits the eye, or possibly the brain, who triggers this light flash. And I've been part of doing research with experiments with kind of detecting particles coming from space through a detector and then hit the eye, and we kind of noticed that with some bottom and then tried to correlate these things. And we found that the probabilities for how it happens is more probable for heavy ions than protons, for example. So KTH, I brought KTH to space, let's say, and I actually brought a couple of things. This one here, the very first one, was brought to space, and now there are some others around. And I also brought this one here. So now you can see it there. And this is a little detector demonstrator of the radiation up there, which varies where you are in orbit. And that was built at KTH, was then took pictures of it, video, and we had similar of them, which was then used to go around schools and kind of educational demonstrator. Since 4.5 years, I'm back at KTH, and one of the first things the then rector, Peter Gudmundsson, said, hey, let's look at KTH. What are we doing in space? And after a while, we realized we're doing a lot, and that resulted into we created the KTH Space Center. And the inauguration was in May 2014. We launched a rocket, not really that one, a water rocket, a rocket in F1. And it's around 90 researchers at KTH involved in some 20 space-related projects. What we do, we coordinate and try to find synergies for space projects here. We build up general support. We are right now building a space technology lab such that researchers here can test their equipment for space. And we're doing that in cooperation with the industry. Startup support for people idea and want to do something. Anyone here has an idea you want to do something in space? So apply money from us. You may get it. Outreach and conferences. We had a conference 2 years ago with almost 100 astronauts. Actually, we inaugurated this Domo Vision during that conference with the astronauts. We do teaching, student projects like this one here, Rexus. That's a rocket experiment launched in S-range for students building experiments. A very big student project we have is MIST, and if you stay here until 3 o'clock, Sven Gran will talk about that. Sven Gran over there who's leading this. So this is a small satellite, but this size, who are really built by students. It's a learning teaching project, and we hope to launch it in a few years. But it also has 8 experiments in it. You can learn more about it later. Here are some examples of the various research being done at KTH, and many of these you can learn from during this night. Building hardware structures, electrical structures, or electronics who can survive on Venus. That's a real challenge. Astroparticle physics with both balloons and satellites. Human physiology will not be talked about, but how you use GPS signals to do research also. And one of the prime research related to space at KTH is electromagnetic fields. That's a heritage of Hannes Alvén, and I think Göran will be the next speaker talking about that heritage. My own research is still about particles in space, but I now moved into interest of the highest energetic particles. They are like protons or iron nuclei, but they have as much energy as a tennis ball coming from a hard smash. And it's incredible to understand how can such subatomic particles get so much energy. And that's what we want to understand. And when they hit the atmosphere, they create the kind of shower in the atmosphere. And and then it produces UV light, and that can be kind of picked up as a video from space, from the space station. That's our plan. The idea why do it from space? Well, they're so rare, very, very rare, maybe 1 in 100 square kilometers per year. And you want to observe a big area at the same time, and that's why we want to do it from space. We don't have the money yet for the big experiment. That's the problem. It's very expensive. But we have money to do a small experiment, which will be launched to ISS in about a year, a kind of testing the technology and do some research. It's probably too small to really pick up one of these particle events, but we can measure the UV of the map of the Earth in the night. We can measure high altitude phenomena like lights, meteors, and something called strange quark matter, which probably doesn't exist, but we can at least put a new limit on it. So I'll finish off a little bit of kind of how you can play in space also, or research, let's say. Let's call it research. So how does water behave in space? Well, it just floats around when you leave it like that. You can study the dynamics, here you can study the optics, you can see how the light is. Here you can see the forces which keeps a space shuttle in orbit in this water planet. You can test making a submarine. And we move into multi-particle dynamics here with a lot of shuttles. And going from physics to medical science, you can see what happens with your body if you try to swallow that. You can also call it simulation of black holes swallowing a planet. So with that, thanks a lot for coming here. I hope you stay, as I said, and congratulations to KTH for our wonderful campus here for 100 years. And follow all these other guys tonight. Thanks a lot. Bravo.